Well, hello, and welcome back to another quarantine vlog. I want to stop calling it quarantine at some point, but we're still in quarantine. Okay, what I'm doing right now is I'm counting and kind of making sure that the inventory that I think I have in the spreadsheet is actually what we have, because I know we were off on this part. This is the spacer that goes in the back of our knives that holds the handles apart. So yeah, Eric thought we were out, but I found a bag because we're not the most organized, but we're working on it. So yeah, I'm just counting everything, make sure that I know exactly how many we have. And then same for the screws that we make. These are the knife screws that hold the handles together. So each Norseman has 7 screws in it, so they get eaten up pretty quickly, and they're not the fastest part to make, even on the Swiss. So this is all that we have. Divided by 7 is not very many knives. So that's what I'm doing to start my day. Okay, let's do all Kern stuff in this video. I broke some tools on the Swiss. I'm not going to get into that. I'm going to leave it alone for now. Not a big deal, but just annoying. Anyway, so I have a 1/4" drill bit that I mounted up. I'm going to put it in the tool rack. Like I've been saying, I started to lay out my tooling organization, and I decided to put the drill. This will be 155, which goes right down here. But if you can see, it don't fit, because there are 2 rows, that row and that row, that are shorter. And then the upper rows and like most of them are really tall. But I gotta remember, from 103 to 156, I can only put short tools. And a drill is kind of typically longer than normal. So, bummer. Okay, so I just gotta re-strategize a little bit. So I've been talking to a few of my buddies over the past week or so about organizing a tool rack. Some guys say, don't worry about it. Just name your tools really well in the software, and then you can sort them by name, and then you can find anything super easily. Like on the Mori, it's a random pot generator. So that tool might go back there next time, and that tool might go back there next time. It's totally random, doesn't matter, because you look it up in the program. This, because it's so bookshelfy, I want it to be visual. I want to see ball mills there. I want to see flat end mills there. But maybe it doesn't matter. But like I was just saying, with those 2 racks being shorter than the rest, I think I'm going to screw myself here. It's not going to work. Because if I say, okay, all the ball mills go there, this ball mill won't fit. This one will. I put this one in. It's like, what's that, number 6? It just fits. I wouldn't go any longer than that. Whoa, careful. So yeah, and corner radius, that's a super long corner radius. I'll probably have a long flat end mill too. So I don't know, man. Maybe I'll just throw the spaghetti on the wall and see what sticks, and be not afraid to update it over time, which is probably what's going to happen, because there's no way I'm going to guess properly now. So let's just move on and make stuff. So when I drill the pallet, where'd it go? Right here, sideways. I have to drill a 5/16 hole, a .3125 hole, for an M8 bolt to like slip through. The only drill I have in that size is a high-speed steel drill, which just feels gross to use. After using carbide for almost everything for so long, even a high-speed steel cobalt drill is much better than a regular HSS. It just feels gross, and this thing's already like used and beat up and kind of nasty on the sides, and whoa, feels gross. But I'm not gonna, it's Sunday, I'm not gonna go buy something. I'll make it work. It's complaining. It says the tool's too long. It'll go up, it'll measure it, but then it'll just complain and cancel and go back to normal. So 5.9-inch tool, 150 millimeters, what they said, and the 5.9 is actually under 150, that's what I'm telling it. But it's probably just ever so slightly longer than 150 millimeters. So I'm just gonna have to loosen the collet, shove it up a little bit more, and then try it again. Next up, we are looking at thread mills. So a thread mill is a sweet way to make a threaded hole, as opposed to a cut tap, like this gnarly aluminum cut tap. Come on. So that's a spiral flute cut tap. I love using those for aluminum. This is a straight flute cut tap. I don't like using these as much, but they work, whatever. Tiny little guys, bigger guys. We got some tapered MPTs. So yeah, cut taps work well, but a thread mill is awesome too, because you drill a hole or you bore a hole, and then this guy goes, it shoves down to the bottom, and then it interpolates outwards, and it cuts a thread on its way out. And you can do multiple passes, 2, 3, 4, and you can dial in the exact thread size. That's why I like using these. And this is, I basically got from Lakeshore, I basically got the range of everything I could realistically need to cut anything from a teeny tiny, like, what's this for, 256 or something? I think that'll do down to 256. Some 440s, M6, M8, quarter 20, like whatever. And you can use, as long as it'll fit in the hole, it can cut a multitude of range of sizes. So that's pretty cool. So I'm gonna load all these up so that I have them, because eventually I'm gonna need a lot of them. But right now I really just need, I forget, one of these two. Been spending quite a long time setting up all these tools. Setting up the tool database, setting up the Fusion database, also having my own Excel spreadsheet, Google Docs Drive spreadsheet, Google Sheets, that's what it's called. I'm losing it here. Been at it for quite a while. Always try to orient the letters forward so we have consistency. Alright, it's coming together. I had to rearrange a whole bunch of times because this is starting to feel stupid but also amazing at the same time. So essentially, what am I doing here? Ball mills will be there, flat end mills will be there and there. Long thread mills will be here, short thread mills will be here to here, because I do a lot of small stuff. Short drill bits will be there to there, long drill bits will be there to there. And then chamfer mills will be from there to the end, because most of them are short. Any longer ones can go somewhere else. It's a little restrictive having the short ones and trying to organize at the same time. Alright, so in the computer we have Tool 84. I put it in spot 84. I've given it a name. I'm not sold on my naming convention yet. It just works for me right now. I measured roughly 4.7 inches, roughly 0.15 radius tip. Okay, so end we go to, we are calling tool 84, enter, and then we just go cycle start, everything's good. It's grabbing the tool with the robot arm. Almost ready. Almost ready. Oh. Cabinet door not closed. Doi. Duh, 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 duh. That might work. Oh, it's doing it right now. It was just waiting. That's kind of cool. Okay, this one's kind of long, so I'm gonna, since I have one hand with the camera, so I'm gonna scroll down on my awesome MDI screen to the tool setting thing, cycle start. I'm gonna slowly go forward because this guy's kind of a longer tool, but it should be fine. Oh yeah, there's plenty of room. Yeah, we're good. Thread mills are a little tricky to get the diameter of because they're pointy and you gotta aim the point perfectly. So I've had to guess a couple times and guess up and down and log the results and get it until I get the biggest diameter out of the tool. So you can see the red light on the side of the tool. That's the laser. So radius should be roughly 1499. I am very, very happy with that guess. So the setting here, 0.3, if I try 0.32, measure the diameter, 0.28, measure the diameter, I'll find the high spot, although I'm pretty happy with that. I've got 2 fun facts for you guys. Fun fact number 1, it's touch setting right now. Fun fact number 1, when I wear my hood inside, it means I'm really tired. I don't know, I can't explain it, just when I'm tired, I'm like, whoop, and I do it at home, I don't know why. Fun fact number 2 was, oh yeah, when holding the camera and trying to actually do something, like when I'm facing it forward and trying to do something with my other hand, it's amazing how much brain power you lose while trying to film. Like maybe it's because I'm tired, but I've noticed it for my whole filming career. Like your cognitive ability does get reduced ever so slightly while you're trying to film and explain it to somebody else, and that's why I have my yellow safety vest to focus and to be able to concentrate. And it is a little bit harder while on camera, and I just wanted to share that because a lot of you guys might not realize. So yeah, but I'm doing my best. All right, the next step we're taking is when I roughed out that surface, I left 5 thou of material, which is like just over the thickness of a hair. And I'm gonna come in with an 1/8 inch flat end mill, and I'm just gonna skim that little last 5 thou off. Notice how I'm plunging outside the stock and feeding in, just so I don't have any plunge marks or dwell marks on the stock. I'm pretty sure this is just a simple 2D pocket operation, because I also wanna go around those bosses. It's gonna take forever, but I don't really care. Just skimming that 5 thou off, I just want it to look super duper good. Step over is 50 thou for a 0.125 end mill, so it's baby steps. But things to keep in mind as well. I mean, I have to remember that not everybody is super experienced at this. So that tool right there that's only cutting 5 thou, not very much at all, theoretically that's gonna wear the tip of that tool, just that 5 thou. So if I'm coming in and profiling around these bosses, you can see that there's a bit of stock left right there, and there's a bit of a radius at the bottom of the boss from the roughing tool. Technically, the tips of that finishing tool could be worn by the time it gets to the boss here, plus cutting that extra little meat. So the sidewalls of your boss should be as accurate as you probe the tool, but the bottom might be a little flared out. So as I'm making the mating joint that goes onto there, the hole, I'm gonna just put chamfers on there to eliminate that. But if I was super picky, I would do this finishing pass with one tool, and then I would finish just the bosses with another super clean tool. And these are just little tips and tricks you pick up, and most of the time you don't apply, but sometimes you do. So this is one of those tools that I want to be super duper accurate for the diameter of, so I'm going to use my sticky tack. I'm going to make sure that all little hairs and dirt and finger, you know, skin cells and dust and everything is off of there. It's a brand new tool. And it should be accurate now. All right, tool 55. Okay. .125 flat stub. Length was 3.66. Diameter 0.0625. And then I scroll over here and I tell it that it's a milling tool. If you go like this, you can see all the types of tools. This is for tool grouping, which I might use later on, I don't know. And then I have to tell it where I want it to probe on the center line of the tool, which I want it right in the center. And then when it's probing the side of the tool, if I want it to come up, like for a radius tool, you don't want to probe at the tip, you want to probe up at the top of the radius. So, I mean, a little bit is fine for what I'm doing right now, 50 thou. That's it, and then I can go into, I can call the tool. Getting kind of good at this. Tool 55, end. Cycle start. Robot's grabbing the tool from the other side. Any second now. All right. And then I just scroll down 2 times to the measuring cycle, hit cycle start, and it's pretty easy. I mean, I like Heidenhain. It's pretty intuitive once you understand it and wrap your head around it and get some experience going. Come in from the side, hit it from one side, and then it goes to the other side and hits it from the other side, getting a true center. And I think it's set to tap it 3 times. You can just see the laser beam there. And that is about it. Another fun fact about end mills. So the end mill shank is usually really tight tolerance, like 2/10 undersize. Like instead of 250, it's 2498 or whatever. But the cutting edge is almost always undersized. So I remember when I was new to machining, I was like, oh, it's a 1/4 inch end mill. And you just always call it 1/4 inch. And you're like, why is my part out of size? Well, these are not actually 1/4 inch. And it's because in order to create like a sharp cutting edge, they got to bring the whole diameter down so that they can actually cut the outside. It makes total sense once you understand it. So like this guy might be, if this is 250, this might be 248. Typically a cutting edge tolerance is a 2 thou range, +0, obviously you can't go bigger than your shank size, -2 thou, which is, it's kind of a mile when you're trying to make accurate parts. So using the laser, or like on the Mori we have the touch setter where the tool spins and it bumps up against the tool setter. Being able to measure your actual diameter will help you get more accurate parts. And even if you have to go in there with a micrometer and measure the flutes, it usually works fairly well to give you at least a ballpark of how to make the most accurate part. My point exactly, that 1/8 inch flat end mill we just put in, 1/8 inch flat stub, measured a radius of 0.6223. So just for fun, let's go 223. No, that's what? 22. Come on. 23 times 2. That's kind of small. That is a bit smaller than 1245. 6. Okay, it's 6/10 under, but it's still under. It's still under. That's better. I'm waking up. Okay, the last tool we need to set up is a 1/4 inch ball in a PG-15 holder, which is PG-15, 25, 10, PG-15, and PG-15 quarter. So we got all the collets organized. This is my 1/4 inch collet stack for PG-15, and Angelo set this up. I'm glad he organized it like this because it's making it very easy to find stuff. Alright, pull the collet out. Whoop. These things are gorgeous. They're coated with something. I don't know what it is, but gorgeous. 1/4 inch Lakeshore carbide ball end mill. Fits in there like a glove. Ooh. It's such a perfect fit that, check this out. The laser engraving, where it says USA right there, it actually raises the tiniest bit of a burr. So I can feel ever so slight the grippiness from that laser engraving. And different companies put more or less effort into the laser engraving. When I was at Milterra or Zadaro Tools, they were telling me that they put a lot of effort into their laser engraving. And they're actually like measuring the growth thickness of the laser, and maybe a lot of companies do this, but Zadaro was telling me about it. And they're like, oh yeah, it's got to be shallow, yet still readable. So that was cool. Okay, pull out this guy. So this is a PG-15, the kind of medium size for me. Collet goes in, tool goes in. Woo. Get my stick out to be 0.750, which I've already determined. Use my piece of sticky tack to set the height so it doesn't fall down. Almost. It's not moving. The sticky tack's working too well. .753, 752, 751, 750. I think that's good. Ah, 7545. 76, 760, 758, 756, 753, 750. Okay, I'm gonna try that. This thing's awesome. Done, son. Double check my height. I've had to do this a couple times, sometimes. Okay, depending on how crooked I'm measuring here, I got 749, 751. It's finicky depending on how you tilt it, and I'm doing my best, but I'm just saying there's a little bit of variance. And that's the funny thing about tools too, is everything's compliant, everything bends. If I squish on an object and I push really hard, I'm gonna get a false reading. If I push, ever so gently, maybe I'm not gripping tight enough. If I'm crooked, then maybe it's not accurate as well. So there's skill to everything. I mean, big surprise, but as a new machinist, a new, guy who makes stuff, you're always learning, you're always trying to figure it out, you're always guessing, and a lot of times you guess wrong. I've been at this for 12 years, I've guessed wrong many times, but then you push yourself and you push yourself and you get better and you get better, and then eventually you learn and you read stuff, and Instagram's been amazing for sharing of knowledge and stuff, but little tips and tricks don't always come through, so you just gotta figure them out yourself. Okay, next thing is I gotta measure my rough gauge length. Gotta be careful on this ground surface here, I'm just guessing. 3.92. Back to the machine. And then we'll do everything you've seen a couple times already. What did I say, 3.92? For tool number 32. 3.92. That is 3.92. All right, let's hit it. First operation. Man. All right, first operation, let's hit it. See if I can manually focus this thing and make it so the autofocus doesn't go crazy. If I can get past this blank spot in the window. Going handheld. Back to autofocus. It's like there's nothing to look at. It's just coolant. But it's cool. Sweet. I can hear it cutting ever so slightly. I notice that as it's cutting right now, as that lifts up and moves back, it's going slowly on the retract. So there's a setting somewhere in Fusion that lets it, wait, it just did it, that lets it go fast on retract, and sometimes it goes slowly on retract. See, now it's going fast. What the heck? Sweet. Man, this thing's fast. The rapids are really, really fast. Here's a little fun thing. See the little scroll bar right there? It actually seems accurate on that machine and on that machine, and well, maybe it's the Tornos, but on the Nakamura, that scroll bar is never accurate. It's like it doesn't know how much more code is left. I'll be happy if this is true. So while that beautiful beast is cutting away, I'll tell you real quick what happened with the Tornos. I was running it this morning, making more of those pivots with the beautiful ground face on them. Everything's going great. Until I noticed that finished parts were coming off with... Where are you? Come on. Finished parts were coming off with that burr, that swirly chip wrapped around them, which led me to wonder if, oh, my fingers are all oily, led me to wonder if the part-off blade was chipped or worn out, and it totally was. So I pulled it out, flipped it around to the other side. The other side was, actually, I hadn't thought about this. I looked under the microscope, the other side was a little bit worn out, but not nearly as bad as what I'd been running so far. It just had a little bit of, I don't want to call it built up edge, but just a little bit of fuzziness in the front. But I was like, all right, it looks almost brand new. So I throw that almost brand new edge in. I was like, I don't even have to touch it off, because I don't. I just replace the insert, it's close enough, it's good. And then walk away, and I don't know, I heard a little bit of a ting, not much, and then I get a Z1 excess error alarm, and I'll show you in the machine. So I still don't know, like, exactly what happened or why, because I just gave up and haven't thought about it. But somehow my through coolant drill bit is broken, and those things are like 50 to 100 bucks. My spot drill is broken, and the threading tool that's stuck in there right now is almost definitely broken, and those things are like 50 or 80 bucks. And the part-off blade right down there in the back is definitely broken and cracked. Can you see that? So I don't know why. Something went wrong. I cleaned the part off the insert pocket before I tightened it. I torqued it down with these awesome Weehaw torque wrenches. It clicks when you reach the right torque. That one's obviously a T7. The one I used though was a T8. So I don't know why I did it. Something's wrong. I don't know. I gotta figure it out. Not today though. You know what's happening today? Let me show you what's happening today. Ba-bam! I already turned the air off. Ba-bam! Good night, problem. It's midnight. That looks so cool from far away. just the B sideways like that. So much coolant. Here's a fun fact about the coolant. So it all drains down to the bottom, right? The chip conveyor goes there, goes all the way back. I really got to turn that thing on. It's this gray thing here. Chip conveyor. So this is all full of coolant. Like, through this hole, I can stick my finger in there. That's coolant. This pump periodically has float level switches right there. Every however long it needs. It'll pump the coolant into that unit. That's the chiller, paper band filter, all that stuff. Well, it's turning on right now. So yeah, it evacuates the coolant from there, shoves it in there, and then that goes back to the machine, and then it's this constant loop. And then the chips will come up the chip conveyor into a bucket that doesn't exist yet. I like where that scroll wheel is at. That means we're almost done. Cycle time is 13 minutes just for this little facing operation. Guys, I'm going slow, I'm going light. I don't care how long it takes. Don't matter. All right, let's check it out. Door open. It looks really cool. It's yet another mirror. Check out that tool path. Oh, it's hard to see through the reflection, but wow, that's a cool looking tool path. And he's so shiny. I can feel it. Yeah, I can feel little ridges. It's not the flattest thing in the world. Man, taking off 5,000s wasn't enough, or was too much. Or I need to go slower or something. Interesting. It's fine. I'm happy. That's a cool looking part. So I got one last code. I'm just gonna drill. I'm gonna spot. I'm gonna drill. I'm gonna do a little bit of chamfering around the outside, and then I think we're good. You know, it was a better finish before with the 1/4 inch end mill, the 1/4 inch radius corner end mill. I mean, looks amazing, but all right, definitely running out of steam here. But made my part. Measured my features with my micrometer, and I was like, why the heck are these posts too big? They're measuring 2504. They're supposed to be 2495, so they're 9/10 big in diameter. And I'm like, the heck? So remember when we're measuring the diameter of the tool and the actual size versus the theoretical size? Well, in Fusion, I just told it the theoretical size and didn't tell it to look at the machine to know the actual size using cutter compensation. So I did in computer, I needed to do in control for the finishing pass. So I'm just gonna zip out another finishing pass, zip around those posts one more time, and it should be bang on. So I've drilled the hole. Next up we have the thread milling operation. I turn the coolant off for viewing pleasure. Oh baby. But I'm gonna turn the coolant back on. Makes the tool happier. So I picked up a thread gauge from McMaster in order to dial in these M8 threads. And is it just me, or is this thing not supposed to come apart right when you buy it? I mean, I've got other thread gauges and they don't come apart. Am I supposed to press them together? I don't know. They're also covered in wax on the ends, which is protective, so I'm just supposed to break that off. But yeah, this kind of is annoying. Maybe it's normal, I don't know. I've got 2 or 3 other thread gauges and that hasn't happened yet. Actually, looking at it, I can tell a taper on the shank. I can feel it with my fingers too. It's kind of cool. Yeah, they're really nicely made. They're ground. They have this kind of thread cleaner outer gash in the front. It's supposed to get all the little dirt and boogers out of the threads as you're going. Go.
I was hopeful, but first try, not even close. It won't go in. That's okay, I got my math wrong.
Well, all in the name of transparency, right? I think I screwed it up. So in Fusion, not today, but a while ago, days, weeks ago, whenever I programmed this, I programmed the thread pitch as some stupid number. It's 59 thou, but it's supposed to be 49 thou. So the spiral, the pitch of the thread is wrong. It's supposed to be 1.5 millimeters, it's 1.51. And if you can see, the two helixes overlap if I were to cut it the correct way. So the dark blue one is what's there now, and the light blue one is what it should be. And I don't think that's good. I don't think that's going to be good at all. So it's 2:09 in the morning. I'm done. I'm turning it off. I will fix it another day. I might have to put in thread inserts, or maybe step up to, instead of an M8 bolt, I'll do an M10 bolt for this temporary pallet. Not happy about it. It's not the end of the world, but this thing's got a lot of work into it already. And the problem is, if I made that mistake tonight, I mean, I didn't catch it, so that's totally my fault, but the fact that I programmed it wrong, like, at home, a week ago, in the middle of the day, kind of makes me feel really stupid. Had I programmed it wrong now, I'd at least blame it on being tired, but whatever. It's fine, it's fine, it's fine. Live and learn. Check your work. Double check, triple check, quadruple check. It's a stupid mistake to make. Anyway, I'm out. Later.